The second and last question on the mechanics paper is a variable acceleration question. So this all hinges on remembering the link between displacement, velocity, and acceleration, and the fact that you differentiate to go that way and you integrate to go that way. So to get from displacement to velocity, you differentiate, velocity to acceleration, you differentiate, acceleration to velocity, integrate, and integrate again to get to displacement. So we've got this model for velocity here, and part A wants us to find the value of t at the instant when p stopped accelerating. So we've got velocity, they're talking about acceleration, so we're going to need to differentiate it, and it will stop accelerating, and acceleration is equal to 0. So we need to differentiate this, set it equal to 0, and find t. So to start with, I think it would be sensible to expand those brackets. So if we expand them, we get 7t add 14 minus 2t squared, take away 40. So if I simplify that, negative 2t squared, add 3t, add 14. So v is equal to that. And I want to find acceleration, which is dv by dt. So if I differentiate that, take the power down, multiply, and subtract 1 from the power, it'd be minus 4t add 3. So acceleration, they stop accelerating when that is equal to 0. If I solve that, that is when t is 3/4. So that's part A done. Part B says find the distance from P of P from O at the instant when P changes its direction of motion. So it's going to change its direction of motion when V is equal to 0. So that's quite important. So changes direction at V equals 0. So it would slow down, stop, change direction, and speed up again. So first of all, we can find t when v is equal to 0. Then we can integrate our velocity to find an expression for displacement, substitute that value of t in, and then find the displacement at that time. So v equals 0. So this is our expression for v. And if I solve that, I get that t is equal to 7/2 and t is equal to -2. Now, can't have a negative time, so we're going to be using t is equal to 7/2. So now let's find an expression for displacement. So I'm going to want to integrate this with respect to t. So add 1 to the power and divide by the new power. And that's going to be minus 2t cubed divided by 3. Add 3t squared over 2. Add 14t. So that is our displacement, S. And then we want to find S at t is 7/2. So 2, so we're going to substitute it in here, minus 2 lots of 7/2 cubed over 3. Add 3 lots of 7/2 squared over 2 at 14 lots of 7 over 2. And that comes out as 931 over 24, which is around, if I round it, 38.8 meters. Okay, so that's question 2 done.